This Stage 1 physics presentation will cover vectors and scalars, which we'll be using across a number of topics throughout this year and next year. Although you have access to the videos and the slides, I'd like you to take notes on all the presentations that you look at. So you don't have to note down every single thing that's written on the slides, just focus on the points that are bold, the definitions and the equations. So I'd like you to pause the video, grab your textbook or your notebook and start taking notes. Okay, so for the vectors and scalars topic, we're just going to look at what a scalar quantity is first. So the definition is that the scalar quantity has magnitude but no direction. Some examples of this include mass, time, speed, and energy. Now with vector quantities, they have both magnitude and direction. So magnitude being a size or represented by a number, and also a direction which can be represented by an arrow or in words or an angle, just something to represent the direction. It depends on the question. So an example of this will be displacement, velocity, acceleration or force. And we'll go through a few examples throughout this slide. Although vector quantities and scalar quantities both have a magnitude, only vector quantities have a direction. Now this direction has to be measured against some kind of reference frame. For a one-dimensional motion, for example, this is when an object only moves in one dimension. So you can think of something like a number line. The directions that it can move are opposite each other, so being positive or negative, up or down, left or right, whatever the question is. When we draw 2D vectors, however, we need a little bit more information. So to draw a vector, we can represent this by a line with an arrow, where the length of the line represents the magnitude of the vector, and the arrow represents the direction that the vector is pointing. So in our example below, we've got a reference of north and a scale of 1 centimeter representing 1 Newton. So our vector, which is this arrow here, is 5 centimeters long, representing 5 newtons. And you can see it's pointing northeast, so that's 45 degrees to the north, representing the direction of that vector. We can also perform operations with vectors. So it's very similar to addition, subtraction when we're working with numbers. However, as direction is also important, we have to take this into account. So we've got an example. If we wanted to add 4 newtons north and 3 newtons east, we have to remember to put them in the vector format. So one way we can do this is using a scale diagram. So looking at the example on the right, we've got our 4 newtons north represented as a line 4 centimeters in length pointing north, and then you can see at the end of it we've got a vector pointing east, which is 3 newtons long. Now our result goes from the start, which we started here, and it finishes up here, and so our result is this 5 Newton vector pointing in that direction. So using a scale diagram, we can find this 5 newtons by using a ruler and measuring it. We can also use a protractor to measure the angle here. Scale diagrams can get a bit complicated and time consuming and might not always provide the best accuracy of measurement. So another way we can do it is mathematically using Pythagoras' theorem and trigonometry. So looking at the same example, we have a vector 4 newtons north, another one 3 newtons east, and we can see that because they're independent, meaning there's a right angle, we can use trigonometry and Pythagoras. So using Pythagoras, we can use the formula a squared plus b squared equals c squared, and we find the magnitude of our result being 5 newtons. We can also find the angle, which we'll look at on the next slide. So rather than using a protractor, we can use trigonometry. So we can use our tan rule, where tan is the opposite over adjacent. So the opposite to this theta is f2, and adjacent is f1. So tan theta equals 3 over 4, and if we find the inverse, we find that we get 37 degrees. Now, we have to put the answer together because we were looking for the result. So the final result is given as 5 newtons north, 37 degrees east.